Hi, Assalamu alaikum. Can you all hear me? Okay, great. So tomorrow, inshallah, we will have a meeting with the other group members regarding your midterm exams. So after the meeting, I will inform you about the decision when the exams will take place and what will be the mode of exams and what kind of questions will you be expecting? Is it multiple choice or this thing? What do you call it? Calculations, essays, or something like that. So I will make an announcement, inshallah, tomorrow after the meeting. And also, we need to write our first quiz because we did not write any quiz so far. So next week, we will have a quiz, and I will let you know. I will inform you about the date. I will tell you. I will send an announcement regarding the date. So I will send two announcements. One regarding the midterm exams, and the other one the quiz exams. So inshallah, tomorrow I will let you know. And even no, I mean tomorrow we will have a meeting, departmental meeting to decide on the date of the midterm exams. So if we decide after the decision, I will send you a message regarding that. And also, based on the date of the exams, we will decide on when to write the first quiz. Okay. So I will send both announcements tomorrow, inshallah. So you should watch out your blackboard. I will send the announcement through the blackboard. So this is it. So anyhow, the exams will be from chapter 1 to chapter 3. Chapter 4 is not included. That is, this chapter is not included in the midterm exams and also in the quiz. So you should just focus on chapter 1 to chapter 3. No, I said I will have a meeting tomorrow with the department, so that we will decide on when to give you the exams. So definitely the exams is not tomorrow. It might be next week, but in any case, I will send an announcement on Blackboard regarding the exams date. Okay. Okay, great. So last class we discussed about effective interest rates, nominal interest rate, compounding period, and so on. So today we will look at compounding when you have a continuous compounding. So when the interest period is very small, if we allow compounding to occur more and more frequently, that is when you have compounding to happen very frequently, that is maybe every month or maybe weekly or something like that, then the compounding period becomes very short and short. That is the short period when compounding occurs will become very, very small. Then M, that is M from this place here, will become it will increase. That is, you will have a lot of number of M's. This maybe if you have small compounding period, then maybe this will be small. Yeah, that is maybe you're compounding at quarterly, then this M will be 4. But if you have the compounding to be continuous, then it will be the period of the compounding will be very short, very small, very small, very small. As such, the number of compounding periods will be high. Okay, so you will have high number of compounding periods. And this situation occurs in businesses that have a very large number of cash flows every day. So this is typical of businesses that have a very large number of cash flows every day. So because of the cash is flowing a lot, you have a lot of transactions and so on. So it is correct to consider interest as compounded continuously. So as m approaches infinity, that is, it is very large. Now you will have a new formula to calculate the effective interest rate. So this will not be the normal formula like the way you have it here, or this one, for example. It will be like this. It will be in the effective interest will be I is equal to e raised to the power of r minus 1. So from the question, you can be able to determine if the compounding is continuously or not. So if it is a continuous compounding, then this is the formula you will use to calculate the effective interest rate. And we will look at this example here. They said for an effective interest rate of 18% per year, So this is the interest rate is 18% in 1 year, compounded continuously. So you see they have mentioned that the compounding is continuous. So you'll be what will come into your mind is use this formula. So compounded continuously, calculate the effective monthly and annual interest rate. And now they want you to calculate the I, that is this guy, effective interest rate for on monthly basis, and then annual interest rate as well. So the nominal monthly interest rate is equal to the interest rate in 1 year. You divide it by monthly, since the first question is asking you to calculate the effective interest rate monthly. So now you have the interest rate given annually, that is 18%. And once you want to convert it to monthly, you just divide it by the number of periods, which is 12 months in 1 year. And this will give you 15% or 0.015 per month. So once you have this, now this is your nominal interest rate R. So you just plug it into this equation, and you can calculate the effective interest rate. So once you put it like this, then your effective interest rate per month will be like 1.511%. And similarly, the effective annual rate will be 0.18 per year. So it will be the same thing, 18% per year, because they are giving you, this is the annual interest rate, and annually they're asking you to calculate the annual interest rate, which is 18 times 1, which is 18. If you divide it by 100, you will have 0.18. So if you plug it into this formula, your R will be 0.18. Then you do the mathematics, you will have this. So this is your annual effective interest rate. So this is another example on this calculation that involves compounding, continuous compounding. So in this question, they said if a person deposits $500 into an account every 3 months, so you have every 3 months, the guy deposits $500 into his account at an interest rate of 6% per year. This is the interest rate, the annual interest rate. And they said it is compounded continuously. So this formula will come to your mind. How much will be in the account at the end of 5 years? So they're asking you how much will be in the account after 5 years, given this annual interest, and then this deposits in every 3 months. So the payment period will be 3 months. So you are paying $500 into the account in every 3 months. So payment period is equal to 3 months. Now quarters in a year, you have 4 quarters, because you are paying 3 months, and that will give you a quarterly distance, because 12 divided by 3 will have 4. Then the nominal rate per 3 months will be your annual interest over 4, and that is what will give you the nominal rate. And once you find the nominal rate, you need to find the effective rates in that 3 months period. So you have R, which is your nominal rate that you just calculated, divided by 100. You plug it into this equation, and then you calculate your effective interest rate for that 3 months. Once you have the effective interest rate, now you need to find the future amount, because they said how much will be in the account at the end of 5 years. So they're asking you the future amount, how much in the future will be after 5 years. So now you have F is equal to 500, which is the amount, F over A. Now given A, you need to find F. And now this is your effective interest rate now. And this is the period, because the period now is the period will be 20, because this is you are talking about 5 years, 4 months. How many 4 months you will have in 5 years? So it will be 5 multiplied by 4, which will give you 20 months or something. That is the period in which you will be given this deposits. Yeah. So if you go to the table, of calculating F given A and then the corresponding interest rate. You will do the mathematics and you find what is inside this bracket. Then you multiply it by 500 and you get this. Or if you decide to use the spreadsheet function, you can as well do the remember the function here. You put it and then put the parameters, and then it will give you your answer. So now, if there are certain relations that you need to know. That is, sometimes you will have your payment period. That is the length of time between cash flows in the diagram. So if you have, you are given, you are making payment after every month or after 2 months or something like that. So the duration, the length of payment is not as this payment period. Yeah. So sometimes you have different scenarios. Sometimes you'll have the payment period will be greater than the compounding period. Sometimes the payment period will be the same thing as the compounding period. And sometimes the payment period will be less than the compounding period. So we'll look at this, all of these scenarios and see how we will make a calculation for the effective interest rates and so on when given this kind of scenario. So here, what you are given from this diagram, you have compounding periods here, and then this is compounding period, and then here you are making some payments here. So from here in this table, you can see that the compounding period is $1,000 every month, and then the payment period is monthly. Yeah. So you have also the compounding periods, which is semi-annually. So in this scenario down here, you have annual payment compounding period. So you are compounding annually. So in every year you compound once. And then the payment period is semi-annually. So in this case, the payment period is greater than compounding period, okay? Because the payment period is semi-annually, that is twice in a year, while this one is only once in a year. So this one is greater than this one. When you have a payment period of quarterly, that is the one down here is quarterly, and then the compounding period is monthly, then the compounding period is greater than the payment period, or you can say the payment period is less than the compounding period. So this is another scenario. And then another scenario is when the two of them are the same. So this is when you have a single amount with payment period greater than the compounding period. So you are making a payment of single amount, and also the payment period is greater than the compounding period. So we'll look at how to deal with this kind of situation. Second, let me just take some water. So if you are given I, the interest rate must be effective interest rate. So when you are doing your calculation, you always have to make sure that the I that you are given or that you have is an effective interest rate. If it is not an effective interest rate, then you have to convert it. I will show you an example of this. So like this one, they said how much money will be in an account in 5 years. So they're asking you how much money will be inside an account in 5 years' time. If $10,000 is deposited now as at an interest rate of 1% per month. So from here, you are seeing that you are making one single payment. How much money will be in account in 5 years' time if $10,000 that is deposited now. So the payment is only one single payment. So that is why we say single amount. And also the interest rate is 1% per month. So the interest rate here now will be regarded as an effective interest rate. So 1% is an effective interest rate. And then the time units must be the same as those of an interest rate. So if the interest rate is given on a monthly basis, so you have to convert the N also into monthly basis. So for example, here they're asking you what will happen in 5 years' time. So you have to convert the 5 years into monthly basis, because your interest rate that is given is monthly interest rate. So you have to say, okay, in every month, how many months do you have in 5 years? So you have to multiply 5 multiplied by 12 months. That is 1 year. Multiply 5 by 12 to give you 60 months. So this is what this guy is saying. The time unit must be the same thing as that, so those of 5. So if you're asked to find what will happen after 5 years, then you have to convert this 5 years into what was given to you based on the interest rate. That is, if the interest rate is quarter, and n is the number of quarters between the period, the p and the f. So there are two ways normally to do this kind of calculation. The first thing is to determine the effective interest rate. If you are given the interest rate, then the first thing is you go and calculate the effective interest rate over the compounding period that they give you, and set n equal to the number of periods to coincide with the interest rates. Yeah. So you calculate the effective interest rate. That is what we are saying, and then you make sure that n has the same unit as that of I. If I is a month, then you convert the n that they are asking you into monthly basis. Yeah. Then the second step is to determine the effective interest rate for any time period t. So you have to determine the effective interest rate for any time t and set n equal to the number to the total number of the same time period. So it's just the same thing. You have to convert the I into the n into I to have the same units, and also you must calculate I to be effective interest rate rather than just a nominal interest rate. So this is an example of this scenario when you have single payment with payment period greater than the compounding period. So how much money will be in account? How much money will be in an account in 5 years if $10,000 is deposited now at an interest rate of I is equal to 1% per month? Use 3 different interest rates: monthly interest rate, okay, and then quarterly interest rate and yearly interest rate. So here you can see that the compounding period is less than the payment period, because you have the compounding period, they're asking you something of quarterly and monthly. Then this is like 5 years or something like that. So here for monthly interest rate, for monthly rate, 1%. So this is given in monthly already, and they're asking you to calculate how much money you will have in the account given this kind of compounding, if the money is compounded monthly. So the interest rate they give you is per month, and then the compounding is also, they're asking you to do it in 1 month. So for monthly rate, 1% is effective, that is n. You have to convert n into monthly. 5 times 6 times 12, which is 60. So now you are given amount, and you are asked to find the future amount of money that will be in the account, given the interest rate of 1%, and then the n will be your 60%. So mind you, this is 1% here, and here is 1%, because they're asking you to find what is happening on monthly basis. So it is just the same thing as the interest rate given in the question. You just go to the concerned table, having 1%, you look for a column of f over p, and you find the value and multiply it by 10,000, and you get what you have. Mind you, I and n must always have the same unit. So the I here and the n here, they must always have the same units. N here is a monthly basis. So you have to calculate this one also in monthly basis. So this is 1%, and this monthly 1%, and then this is monthly 1%. But now we have a quarterly case. So this is given a month per month, and this is given per quarter. So now you have to go for a quarterly rate, effective interest rate per quarter. You have to plug it into the formula we just saw, and then you do it here like this. So now you have so in 1 multiplied by 3, because you have 3 quarters in 1 year, so you multiply 1 by 3, that will give you 3%, and then you divide it by 3, and you take the power of 3, and then this is what you will have. So now this is your interest rate, and this is the number of periods. This is 1,000. So you have to convert this, since you have your interest rate quarterly, then you have to convert your 5 years also that you have here into quarters. So this one will converted it monthly, because an interest rate is given monthly. So this one has to be monthly basis. But now here is given quarterly. Now this one will also have to convert it quarterly. Okay. So if payments are made for 5 years on quarterly basis, and then you have to multiply 4 by 5 to give you 20, that will be your N. Okay, I made the comment here, so you can have a look when you go back home. So this is 20 period end, they have the same unit, this all they are in quarterly. Then you look for the table, you multiply this guy by the 10,000, and then this is what you will have. Then for the annual rate, that is C, if you want to calculate the effective interest rate, then this will be 1 multiplied by 12, okay, because this is per month. And then if you want to convert it to 1 year, then you just multiply 1 by 12, which is 12%, and then you divide it by 100. This will give you 0.12 divided by the years, so that is 12 raised to the power of 12, that is the years, minus 1, and this will give you the effective interest rate. Okay, so just mind you, I just want you guys to remember that we're using something like this formula. Yeah, so you have M here, you have M here, you have your nominal interest rate. So you just plug it here, and then you calculate the effective interest rate. You remember, if you have effective nominal interest rate given the period, and then you just plug it here and convert the nominal interest rate into this guy. So we are using this formula all through here. So this is 12, this is 12, this one is 12. So you plug it in here and you get the answer here. So once you have this one, then you need to calculate the future amount given 1,000 as your deposit, and then this guy will be 12%, and then this one would be 5 years. Yeah, that is the number of years. So you make this calculation, and then you have the answer at the end of the day. So there is a scenario also when you have the payment period greater than greater or equal to the compounding period. Here what we are looking at is when you have single payment during these 5 years. But now later on we'll look at series of payments, and also the payment period is greater than the compounding period. So this is what we will look at, inshallah, next week. Do you have any question? This is all we have for today. Do you have any question? Okay. Have a nice time, inshallah.